Imagine it's the year 2045. Every day, millions of packages must be delivered across the world. Inside a massive control center, engineers use powerful computers to plan every delivery route.
Every day, millions of delivery routes are calculated. But as the variables grow, the complexity becomes overwhelming, pushing even the most advanced systems to their breaking point. Imagine standing in a hallway filled with millions of doors. Behind only one of those doors lies the perfect solution, while every other door leads to the wrong answer. Classical computer searches, like a person opening doors one after another. Each possibility must be checked individually, making the search longer, more difficult as the problem grows. But what if there were another approach? What if a machine could explore many possibilities at the same time, instead of checking them one by one? To find that answer, we must look into the quantum world. Deep inside atoms and subatomic particles, nature behaves in ways that seem strange and almost impossible. Scientists became fascinated by these unusual quantum behaviors. They began asking whether the laws of quantum physics could be used to create a completely new kind of computer. The result was quantum computing, a revolutionary field designed to tackle problems that are far too complex for even the most powerful classical computers. But how can a quantum computer approach problems so differently? The secret lies in the way it stores information, using something called a qubit instead of a traditional bit. Quantum computers may one day solve problems that challenge even the most powerful supercomputers. But what makes them different from the computers we use today? To understand the difference, we first need to understand how ordinary computers store information. Every photo, video, game, and application ultimately depends on something called a bit. A bit is the smallest unit of information inside a classical computer. It can exist in only one of two possible states, 0 or 1. Think of light switch in your room. When it is off, it represents 0. When on, it represents 1. A bit works a very similar way. However, one bit alone cannot store much information. With 2 bits, 4 different combinations become possible. 0, 0, 0, 1, 1, 0, and 1, 1. Now let's add a third bit. The 4 existing combinations instantly expand into 8 unique possibilities. By adding just one extra bit, possible states doubles again. These bits allow computers to represent information. But representing information and solving problems are not always the same thing. As deliveries increase, the number of possible routes grows rapidly. A classical computer often evaluates these routes one by one, slowing the search for the best solutions. So scientists began wondering, could there be a new way to store and process information beyond traditional bits? The answer came from quantum physics. Instead of bits, quantum computers use a new unit of information called a qubit. At first glance, a qubit may seem similar to a bit, but there is a crucial difference. A bit must always be either 0 or 1, while a qubit follows the laws of quantum physics. Unlike a qubit is not limited to a single fixed state. This flexibility is what makes quantum computing so exciting. See how information grows. With 1 bit, we get 2 possibilities. With 2 bits, 4 possibilities. With 3 bits, 8. Every new bit doubles the possible states. Notice the pattern. Every new bit doubles the number of states. This follows a simple rule. N bits can represent 2 raised to the power n states. Qubits follow a similar pattern. With just 10 qubits, more than 1,000 quantum states become possible. As qubits are added, the number of possible states grows incredibly fast. 20 qubits can represent over 1 million states, while 50 qubits can represent more than quadrillion states. This explosive growth is one reason why researchers around the world are investing heavily in quantum computing. But we still haven't answered an important question. How can a qubit behave so differently from a classical bit? The answer lies in one of the most fascinating ideas in quantum physics, a concept known as quantum states. And that is exactly where our journey continues next.